The answer you get when you use any kind of rectangle approximation to find the area under a curve is sometimes called a Riemann sum, after Mr. Riemann, and we're going to find out more about him a little bit later. So the Riemann sum that you find, it's an approximation for the area under a curve. It might or might not be exact. It's very rarely going to be exact. So can you think about when it would be exact? When would using rectangles to find the area under a curve give an exact answer? But so just notice that the same way that we've been able to sometimes tell whether our answers are going to be too high or too low when we approximate, we can tell sometimes whether our Riemann sum is going to give us an answer that's too high or too low. So remember this picture? Here I have a velocity curve, 1/8 t squared plus 1. I remember when I used left-hand rectangles, we said that every one of those left-hand rectangles left a little bit of space. And then when I had right-hand rectangles, every one of these right-hand rectangles was a little too big. So the LRAM approximation for this case was always going to be an underestimate, and the right-hand approximation, the RRAM approximation, was always going to be an overestimate. What makes that happen here is because this function, this velocity curve, is increasing. So if a function is increasing, a Riemann sum, a left-hand Riemann sum, is always going to be an underestimate, and a right-hand Riemann sum is always going to be an overestimate if the original function is increasing. And now you can imagine, what if I have a function that's decreasing? Here, we'll make a picture. If I have a function that's decreasing when I use rectangles to find the area underneath that curve, if I use left-hand rectangles, those rectangles are all too big. So if my function f is decreasing, a left-hand Riemann sum is going to be an overestimate. If I use a right-hand Riemann sum, that's always going to be an underestimate. So in this case, the error has to do with whether your function that you're finding the area underneath is increasing or decreasing. If it's sometimes one, sometimes increasing and sometimes decreasing, we can't make any decision about the error. So they would never ask you on the AP test unless it was very clear what the answer was. Here's an example from a real AP test. Rocket A has a positive velocity. It's being launched upward. Use MRAM and 3 subintervals of equal length to estimate the distance traveled by the rocket. On the interval, here we go, this is important, 10 to 70. So notice they've given us data for times 0 to 80, but they're asking us to only give this estimate for times 10 to 70. So this piece of data here at time 0, this piece of data here at time 80 is not helpful to us. We're only interested in the times going from 10 to 70. We've been asked to use 3 subintervals. So subinterval, that's the distance across the rectangle. So from time 10 to 70, that covers 60 seconds of time. And I need to split that up into 3 rectangles. So each rectangle is going to cover 20 seconds. So from 10 to 30, 30 to 50, and 50 to 70.